Okay, welcome back from lunch, everybody. Hope you're having a good time. We're thrilled today to have Jessica Cobb as our keynote. Founder, inventor, and emerging technologist, Jessica Cobb cultivates systems and communication pathways for industry, educators, and individuals to explore, simulate, and realize new relationships between humans and machines. As the founder of Mission Control Lab, she uses the concept of inventure as a platform to organize the practice of translating ideas, thoughtfully applying creativity, and growing competitive advantage during change. Invention plus adventure equals inventure. Through the practice of inventure, Jessica believes we can use human and machine ingenuity to develop future fitness and cultivate deeper connections between industry, education, individuals, and the planet. Please welcome Jessica.
Good afternoon. I'm going to tell you all about my interpretation of inventure today. There's a few things we have to start out with. The first thing is control. Humans love control. And when we find out that we can have more, many of us will adventure with invention. Invention and adventure have a lot in common. It's actually not the top of the mountain or the end result that causes transformative impact for education, industry, and individuals. It's that process in between, adapting and connecting to the familiar and foreign, that makes massive change. And so today I want to talk to you a little bit about my experience of finding this out and mapping it and where I think we're going. So today I'm going to share with you also some personal stories, which is one of the first times I get to do that since we are here at the Nerd Conference. I'm with fellow developers, and so I think a lot of us can relate to each other, and so I'm excited to do that together today. So we discussed about invention and adventure, and let me see if I can get this to click. And those are those things coming together. So before I started working in emerging technologies, I was on a different trajectory. I was actually doing more neuroscience. And what started me thinking about my fitness was at a lecture about evolutionary biology. And the lecturer came in, threw his stuff down on the floor, and he said, "I have a story for you about Darwin." He said, "If you are walking across the road, too busy looking at your device to look up and get hit by a car and die, this is an example of natural selection. If you can't adapt to technology, you're not fit to survive." And so when we talk about future fitness, I'm actually talking about this adaptability and awareness that's required to move forward. So I was actually working on awareness quite a bit at this research team. And we were actually looking at the HPA axis, how the nervous system, the immune system works together, and how we were kind of programming ourselves to be aware of our surroundings, then change the way our bodies are functioning. So this started getting me thinking, and I looked at a few parts of tech adoption, and the tech adoption is really about feeling in control of what you have in front of you. So you can see here that cellular phones, computer, internet, these are all just going by the world population being adopted very quickly. And this goes across all technology. We're constantly adapting and adopting new technology because it's always expiring, it's dying. And so this is why, from the neurology perspective, I thought, how am I going to survive? How am I going to keep my fitness up if technology is constantly emerging? I felt very uncertain, and I wanted to pivot. So I actually got out of that research And I started looking at other places that were investigating this kind of mentality of new technology and building that kind of technological competency. So I think many of you are familiar with some of these. The maker movement, DIY, do it yourself, do it together, Scrum, Agile, systems thinking, design thinking. These are all great. However, I think there's a fundamental piece missing. That's the person and how you're coming at it as an individual. And each person is so different. And this is where I started to think about inventure. So there's 5 parts of inventure that I want to let you know about. The way I organize them is called orienting, field, wield, yield, and home. So for the next hour, I'm going to break down these different sections for you. And the reason why I break it down this way is I think when we're trying to organize ourselves, it's easier to put things into categories because there's so much noise that we encounter every day. So this is why you'll find out why I organize it in those 5 sections. So the first part we're going to talk about is orienting. And I'm going to tell you a little bit about the hypothalamic pituitary adrenal axis. Okay, so the research team I was working at was looking at how people who had brain damage, had viral, post-viral onset of some pretty severe symptoms, how their body was re-regulating. And one of the ways that we would test it was we would focus on meditation and mindfulness because the symptoms were so vastly different. We were working with myalgic encephalomyelitis or chronic fatigue syndrome. And if you've ever known anybody with chronic fatigue syndrome, it is a lot of suffering, and there's a lot of sensations and very complex issues that are going on at any given time. So one of the ways that we needed to figure this out was how do we get a baseline of mindfulness and see if we can increase our mindfulness in such a way. So we used EKGs, EEGs, MRIs, looking at these different biomarkers where we could start to see if there was change. The meditation that we used was a Zen meditation. It's a mindfulness-based meditation. And what it comes down to is there's a couple of simple pieces to it. And one of them is breathing, is simply the inhale, the exhale. And then, which we're going to come back to pretty soon. And the other one was the foveal and peripheral vision. And if you haven't, if you think about foveal and peripheral vision, it's very acute and obtuse. So foveal vision is when you're looking straight ahead at something in a very focused way. You'll see it here in this image. It can activate your sympathetic nervous system, your fight, flight, or fright, right? That cortisol, the stress response. So that really fine, focused vision is foveal vision. The other one is peripheral vision, this open landscape, like we have this beautiful background behind us. When you're opening your the aperture and you're looking out over space in a bigger way, this brings on your parasympathetic nervous system, your rest, your relax, your recharge. So when I was working with this, I started getting really excited, and I thought, I can make machines that do this. We can create human interfaces that facilitate this, because I think it's a lot of people, even though it's just breathing and looking at a big picture, that's almost too much for people. So I was looking at some different research studies about deception detection, and other items, the frequencies of light. And this is where my tech journey began. And I invite you all to join me on my quite adventurous, non-expert approach towards being an inventor. So we talked about orienting, and when we look at orienting, we're thinking about the familiar and foreign. So I talk a lot about the inner space and the outer space. So for instance, someone might find that a creaky door sound is very alarming and scary, whereas someone else might find that same sound to be exciting and like dopamine effect, my partner's coming home, something like that. So in some ways, we're looking at programming the brain with this parasympathetic and sympathetic response and this openness. And how can we start to associate what's going on in front of us in a new way, so much so that we can be open enough to something that's changing and different without getting alarmed. So this concept of familiar and foreign is going to keep coming back. And it has a lot to do with that breathing, right? And it has to do with the foveal and peripheral vision. So just remember as we go forward that I will keep referencing this. Great. So in the field, it can mean to send out or deal with, or a range of space such as land that is visible, possibly through an apparatus. Great. So one of the things besides familiar and foreign is that it's about that we can, Esther Perel talks about this, it's about the mundane and the exciting. So some of us might find pattern making, doing the same thing repetitively over time, to be absolutely mind-bendingly stressful. It's so boring, it's almost, it causes like these violent feelings of distress. Well, for others, it's actually very relaxing and calming to do the mundane. And as humans, I think over time, we're always designing inside of our experience a way to adjust to the uncertainty of, is it going to be mundane or is it going to be exciting? And so I think that as an inventor and as developers, we really need to have both of them in balance. Sometimes if we've been working really late or we've been doing a really complex problem, we just need to go back and get that mundane thing like macaroni and cheese or something like that. When other times we really are seeking out challenges. So this morning, it was really fun. We did a wearable PCB project with some people here. And as soon as someone was shown how to turn on the light, they went 3 steps forward in the challenge that they were looking for because everybody was ready to charge that uncertainty. And I thought that was really fascinating in this group, and I was wondering what was going to happen with that. So I'm going to show you an example of that later. But every day we're really just throttling through that experience. And in our field, we're influencing our field. So we might be experiencing this on the outside, but how are we actually influencing in that inner space? But how are we influencing the outside, the external, in outer space? And one of the most inspiring movies to me was, and it's a story, was 3 people were about my age. They were going out to the moon. Everything was going well on their mission. They were on trajectory when all of a sudden, during a routine procedure, fatal damage happened to their spacecraft. The oxygen that they were relying on, their system failed. Not only that, they had to reconstitute the power of the entire spacecraft in order to get themselves home. So I thought to myself when I saw this the first time, I said, well, what happens if my systems on board fail? And do I have the stuff I need to get myself home? And so these guys called in to mission control, and people laid out down on a table the materials that the astronauts were going to be able to have to reconstitute the oxygen systems, and then also they were simulating the power controls as well. And amazingly, Apollo 13 got home using something like this, so that they had enough oxygen in their brain to make the decisions and change the power supplies. So this got me really excited, and I said, I don't really want to do neurology research anymore. Maybe I'm too late in my educational journey to about face and go into engineering, but I really want to sit at the table with these engineers. Like, it was so moving to me, that challenge, and the creativity, the creativity that was required. So I thought to myself, I know what I'm going to do. I'm going to build the table. So this is when Mission Control Lab was born. I wanted to create a table where I could be with people challenging themselves, making impact over time, and trying to facilitate these different systems and change. And so this is when I also decided that I have to start making some machines. So what are the first things I did? Because I really like materiality. I really like the transition of, like I said, in the neurology stuff, I really like the transitions of materials. I like the communications. I think that's really exciting. With specialization today, we have all the industries are just specializing infinitely and exponentially. And I think that there's 19 words for the same thing, and we just have to adapt and connect them together. So one of my first ways to do this was manipulating materials. I wanted to make wood behave like plastic. So I made a steam bending chamber. I found a person that would help me make the decisions about this machine, because there's a whole lot of physics going on. There's a whole lot of thoughtfulness around what needs to happen. So, but I decided, like, this is what I want to try to do. I'm going to show up and do it. And at first I started making these lists. It's like, oh, I have to go buy the hot plates at these temperatures, and I have to get, these really advanced machines. And I approached the laboratory manager at the university that I was at, and she said, Jessica, you can go down, you can get this stuff right now in the next 30 minutes. And I said, how is that? That's impossible. Like, how am I supposed to get all these controls and stuff? And she said, it's called a couple of tea kettles and hot plates from the Salvation Army. I think you're going to spend about $6. I was so excited. I ran down the road, and sure enough, we were within a few hours and days of assembling the components, and we were bending wood. And it was absolutely thrilling to me that this is possible. And it was a really magical moment, bringing this concept to life. And I started doing that elsewhere. So I did I did a lot of metalworking. I did actually a welding school, funny enough. And I was working in a foundry, doing lost wax casting for bronze and iron. And then doing some mild steel fabrication. So that was a really exciting time too, getting into that physical stuff. But it was really heavy. I don't know if you can see, like, these wrists really can't handle an angle grinder for that long. So I was very disappointed with my body's ability to manage the tools that I was really excited about. But I still wanted to keep building things. And we were talking about Zen and about light. We were talking about the breathing. And so I got excited about this concept of an hourglass of emptying and filling, and how over time how space is being held and understood. So I think many of you probably know what an hourglass is. In some places in the world, they call them a sand clock, where it's emptying in one place and equally filling in another. So I started becoming a little bit obsessed with this idea, and I started building machines that would behave like this, or that would reveal and conceal at different times. So I had some literal interpretations of this. I started working on you can see in the image on the left, there's this, there's one mechanism. On the right, there's another mechanism that's trying to control light. So like we were talking about, that turning on this sympathetic and parasympathetic nervous system and controlling this light started to become an obsession. And I was lucky. I met some scientists that were just hanging out somewhere, and I was there too, and I showed them this picture, and they said, Jessica, like, come on, have you heard of an Arduino? I said, no, I don't know what an Arduino is. And lo and behold, while I was hanging out at their aerospace lab, I ordered my first Getting Started with Arduino kit. And this is when my programming journey began, and I had this wonderful help by these scientists. So this is the first study of, this is my first project. So then I changed up the power levels. I created some transistor boards. I started interpreting it in different materials. I got into some glass blowing eventually, which I'll show you pretty soon. And I found out about pulse width modulation. Who's heard of pulse width modulation? Yeah! I was so excited. Ooh. I was really excited about this because I wanted to have that smooth, brilliant change over time. Just like, like a sunset and a sunrise is, our brains are so in touch with the sensitivity, the undulation of this light. It's also like the speed of that. As you know, if you're strobing light, you can get epilepsy. In other ways, it could just make you go straight to sleep. So I was really excited about controlling not just the smoothness factor of the light, but also the temperature of light. Because the temperature of light has a very specific response inside your brain for the sunrise and sunset. So I got really excited about this. And I built a few other machines, and I'm going to show them to you soon. But I'm going to show you, I think, I'm not remembering why, but I happen to be an identical twin. And I think that one of the things that inspired me about the neurology back in the day was the passing back and forth between my twin and what agency is. And inside tech, we were talking about influencing earlier. I think there's so much influence that we're receiving and giving. And it reminds me a lot of being an identical twin, because when you're out in public, and I don't know if any of you have identical twins. Is there anyone here? No? If you ever see them in public wearing the same clothes, people are getting programmed that, and I will say that I've had to fight this for my whole life, people were programmed that they're the same person and that they're the same thing, and that it's a group. And I think this is a very valuable insight and observation of social signaling, representation, and then individuality. because especially now, being a part of another is a big part of our human experience. That belonging, the group, but then also having that agency as an individual to be different, to be out of the known circle of a community, I think is something that's really challenging right now. And when we look at tech adoption, it's also a part of that. Oh, you can't do this. You don't have this capability. You've left out of that material of that training. And I think that's a very second industrial revolution mentality that has caused so much limiting ideas for the human evolution. And I think as a identical twin, I wasn't factory made, man. Like I'm also separate. As soon as you leave, even as soon as the eggs split, there's epigenetics. You're changing constantly over time. So actually, my sister is definitely not me. I'm not her. We might look the same, but long and short of it is there's so much behind. And I think as developers and as technologists, and we look at AI and the filtering, is that we're really losing and also gaining some agency. And I like the idea of revealing this in the systems that we participate in. And I think in the next part of this talk, you're going to be seeing my response to this as a systems developer, and how we can start to create the transferring of these ideas into different materials over time. So I was talking to you about being another or other, and the hourglass. And this is a piece that I did as an installation and as a response to that. This is one of the final projects that I did for that study with Arduino. Again, using temperatures of light on each side. So in this piece, I'm demonstrating that loss or gain of agency of seeing yourself inside of your environment. It's and you can interpret that many ways, as a part of the group or as you're being separated from the group. When people were in this room, there was a bunch of different feelings that came out. Some people felt very alarmed. Their brain didn't register it as something that was entertaining at all. It was something really very uncomfortable, where all of a sudden you could see out and be a part of these people wandering around the space, and then all of a sudden you're back into staring at yourself. So I thought it was a really interesting way to discuss and to pair into this kind of agency around technology and demonstrating that. We're going to turn now towards wield. And wield is to have at one's command or to exert one's authority. So I didn't just stop at the welding school. I got into CAD/CAM, computer-aided design, computer-aided manufacturing. I got really excited about the XYZ, and I think some of you will see out over there. This is an XYZ axis, right? And so I turned the Make On logo into XYZ. So I got into XYZ. I started looking at 3D printing, laser cutting, these kinds of things after I was learning how to program and create interactivity. So this was about 12 years ago. I started prototyping, and this, you're going to see another example of the hourglass, but also you're going to see some other prototypes that I was building.
She only wants to count her steps. 18 strides and she stops to abide by the law that she herself has set. That 18 steps is one complete set.
I am a designer, rapid prototyper, fabricator, and survivalist.
She looks up at the blue.
My name is Jessica. I am Emmett Cobb and the founder of Mission Control Lab. I founded Mission Control Lab to bring to the world products that deliver a relished frequency of experience. For the past several years, I've been doing product development for clients, as well as creating interactive installations for public spaces and people's homes. When people experience our products, I want them to feel a sense of self, as well as empower them to do what they love to do in their own spaces they inhabit. The fireplace creates a visceral reaction whenever we see it. Just like in nature, all of us experience this attraction to the warmth and the undulating light that comes from a fire. It creates a sense of focus, presence, meditation, comfort. We use custom LEDs that have a specific Kelvin count, which affect your brain waves in a way that induces a relaxation response. Our fire steel is so exciting because it uses the oldest technology, fire, with the newest technology, 3D printed biodegradable plastic. The vision for the future of Mission Control Lab is to make products that ignite awesome experiences you want to share.
That was my interpretation of Mission Control at that time. I was invited to, so I was spending all this time in these hacker spaces and maker spaces, and I got invited to go teach at the Museum of Science and Industry in Chicago, where I am originally from. Now I actually am based in the Netherlands, just outside of Amsterdam. But I was getting ready to go volunteer teaching over there, and I was walking my dog, and this dog came tearing out of this house and just like bit him, right? Just like he was too close to the fence, and he just reached through the fence and just like chomped my small friend. And I took him, I called in late, I took him to the vet, I got him back, and I left her a note, and I said, your dog bit my dog. I really hope you're going to call me, thank you. And she called me, and I'm in my gear. I look like this. How can you take me that seriously? And she goes, hey, do you know anything about, 3D printing or whatever? I need to find my way. She had a lot of different language for it. She didn't have the language for 3D printing, but I was listening to her. And she said, I'm actually working on this project with an amputee, and his name is BJ Miller. He's a doctor of death medicine. And when he was at, I think it was Harvard, he was hanging out with his friends. He jumped on top of a train and grabbed the electrical top, and he lost his upper arm and his lower legs. And we're trying to create this. There's so many people, we're at war. I mean, this is in 2010, 2011, so this is a little while ago, right? We're at war. There's a lot of amputees around here, and he really wants to work on this, but we don't have somebody that can help us prototype it. And so I started thinking about it, and I said, heck, what we should do is we should make a geometry generating software that adapts and connects to your body's change over time. So, for instance, if you're in the best shape of your life as a military person, or you're in the worst shape of your life because you are struggling with diabetes, how can we get the tech to change with you, or keep you, or either keep what you have or change what you have? And so this is when I was the first CTO of ground control shoes. And we made a geometry generating software that was based on an IoT concept and an Internet of Things concept, where we would be taking the biometric data and feeding it up into our software, and then changing the way that, let's see if we can get this to click. And then we would 3D print it.
Ground Control Shoes has been researching for an alternative to standard prosthetic practices.
Oh, we can let it go.
We sought out improvement for optimal prosthetic performance for lower limb amputees. It's well known that lower limb amputees are at an increased risk of falls due to lack of information from the ground underfoot to the limb, destabilizing the user. Prosthetic users routinely purchase off-the-shelf shoes for their prosthetics, which adversely affects the functional performance of the prosthetic feet. Ground Control directly addresses these problems associated with foot shells and off-the-shelf shoes, providing an intimate fit by securing the prosthetic foot. The outcome increases vibrotactile feedback from the ground to the limb. The secure fit of the Ground Control shoe to the prosthetic foot enables stability for a more faithful walk. Using the speed and precision of additive manufacturing and 3D printing, we can develop and produce end-use products tailored prescriptively for each user. This technology allows us the capacity to manufacture economically. We strive to give access to the masses at an affordable cost. We find that by engineering for the individual, it has a generative effect, evolving science by using data that customizes each experience for improved quality of life.
So that was like the first time that I brought medicine back into my practice. I was really excited because I got to work with different researchers and experts. It wasn't that I had it all figured out. And I think you're going to start noticing that all of the stuff that I've worked on was in a group. We were always doing things together and creating these bridges and pathways through ideas and coming up with something new. So this woman whose dog bit my dog, that started a whole journey. And it was absolutely incredible to be a part of it and do the testing and having the sensitivity around that. And I felt very fortunate that she had the bravery to ask. So this turned me into something else too, which is open fem. So I was looking at, this generative 3D, this generative tech. How can we help women over time? So I think most of you probably know that the fertility and the body, I would say the body composition of women changes constantly over time, from 12 years old all the way to older age. It's not just about contraception and menstruation. It's also about bladder control. Your body gets looser over time. You have to keep things in place. And so we were interested at looking at bladder stents and how can we create a visibility around different anatomies, and then empowering women to be able to go to school or to go function on with their lives in a more personalized way, but also a really accessible way that takes care of that change over time. So that was another project that I worked on that I thought that you would be interested in. But I will say two things as a serial startup founder. The word yield has two meanings. The word yield means an amount produced. It also means to stand out of the way. And one of the biggest takeaways I can tell, and I'm sure you share it with me as a developer, is that there is a huge difference between a probe and a product. And sometimes as scientists and as developers, we're creating this solution to a problem, but it ends up that it actually just becomes a device to let us know more about what we're doing. It doesn't actually launch. And so the two different generative softwares that we worked on with 3D manufacturing were an example of that. We got to expose the market and see more about the interconnectedness of what was going on in the industry for individuals, and the education around these relationships. And so ground control shoes and OpenFem never hit the shelves. Have you ever heard of it? Nope. Was there a ton of work? Absolutely. So I think it's one of those things where sometimes you create a perfect probe. We don't actually get a product. And when we talk about yield in the inventure mindset, we have to be okay with that. That yield is not gonna be us getting a Nobel Prize or having a great bank account full of a generous bank account. It's really that we're creating these probes and exposing things. And in venture, it's that process we talked about that causes impact. So this was all leading up to something that I'm really interested in is the megatrends. And I think, who's here has heard of megatrends? Nobody? Okay. Something like the Global Sustainable Goals and things like clean water, there's no endpoint. Like, where are the activations? We have to enable different parts of the industry, education, individual complex to create these changes. So this is actually in German, but much of it is in English. But you can see that if you look at, like, for instance, urbanization, there's smart cities, there's urban planning, there's all types of creative endpoints or creative access points to come in. And something that I think we should look at as a future of work. So technically I'm in the future of work now. Ever since 10 years ago with all that other stuff, I'm spending a lot of time working with governments and large education think tanks to what is the future of work, how are you creating education and experiences that are going to inform the future engineers, designers, and industrialists. And I think instead of going at it, and I say this very firmly, going at it with like, I have a skill, I think you have to go into it as like, I belong, and I maybe will or will not have the skill, but my meaning and purpose and values in what I'm doing is about creating and having belonging for myself and others, and less about, do I have a coding skill and like, can you slot me into this job? I think in the future of work, people really need to be excited about what they're doing and and what they're contributing to because of that product and probe problem. And I think I'm a really good example of that. Am I an electrical engineer? No. Am I a orthopedic surgeon? I'm not, but I contributed a lot. And I think, and so have my esteemed colleagues. And some people, a lot of the people I worked with, they came from different backgrounds and they contributed to these incredible movements forward. And I think that we have to start inviting people as developers to feel included, even if they don't have training, because there's so much you can pick up on. Like I said, the technology dies constantly. People get fatigued. That's a huge piece of our problem moving forward with the workforce development and reskilling. It's a fatigue factor. you know? I really highly recommend for myself, because I have a lot of energy, but I also get burnt. And I think one of the things that I've really spent a lot of time on is my fuel. So I've done a lot of different kind of biohacking experiments on myself to see, like, what is the best fuel for my body so I don't get so fatigued. What do I really need, and balancing that mundane and the exciting, that familiar and foreign. How do I kind of have my best of all of that? So anyway, I started looking at these systems and spending time on systems, and how do we represent different systems and be able to communicate this way. So at one point, I decided that mission control wasn't about making products that do the thing for the people. I wanted to make products, I wanted to invent stuff that would make people invent and adventure. So mission control turned into being about this mission, and there's two sides of it. There's the hardware side of it and the software side of it, the digital side, and the physical side. And so one of the things that we're starting to do is spending more time on the social network side of this, and people with meaning, purpose, and values. How can we come together with that kind of mentality and do it better than LinkedIn? And that's something that I'm working on right now, is this network. But before I wanted to start doing a social network or anything, I decided to do this, to be a kind of like a Lego-like art material of electronics. And how can we use different symbols to represent different parts of systems? And this is what you see over there. It's called Make-On.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Welcome. Welcome.
Yes. Yes. See. See. Yeah. Yeah.
So the light is not just a light, it's a heartbeat. It's an alarm system. It's a text message. It's the wind turbine coming on. So I wanted to distill down technology into an alphabet that could be used to communicate. So this is why I developed Make-On. and it's a global electronic hardware ecosystem adapter connector. So we looked at how can we make wearables, walls, and objects come alive in minutes with light, movement, and sound, and make it not language free, so that when you do go from LED to IoT, Internet of Things, or from I to AI, that we're going to have a more tech competency, because we're revealing systems that can't be seen. And that was something that I think is really important, that makes people feel they have belonging and access, is just by showing it, revealing it. It also lets people work together better because they come from different systems. So one of the last things I'll show you, which I'm really proud of, is last year we launched a partnership with NASA, and the Jet Propulsion Laboratory, Brandon Rodriguez, one of the scientists there, decided to use MakeOn to communicate how the different Mars technologies work together, and using MakeOn, as we just said, and using it as symbols. So here's a more literal example of.
We have AOS.
So now we're going back to home. We're full circle after the Apollo 13 mission, and that inner space to outer space extension. So I think if we spend some time on systems and becoming connected and adaptive to our environments and being inclusive about it with each other, I think we can have a really great future, feeling more belonging on our planet, and changing the relationship for better and good between humans and machines. And so until next time, have a great inventure.